In this video, we're going to be taking a look at solving absolute value inequalities that have a less than or equal to. A less than absolute value inequality will form an and compound inequality, which is similar to the inequalities that we talked about in the compound inequality video, where we have a three-part compound and inequality. We can do that same thing with a less than absolute value inequality. The way we solve absolute value inequalities is similar to what we do with the absolute value equations. When we worked the equations in section 1.1, what we had to do was create two equations out of the one absolute value equation in order to figure out the two different values that x could be. This is very similar to that. We will actually get two separate solution sets that x could be, and then we will need to combine them. When we have a less than absolute value inequality, we combine the two with the and statement. When we have a greater than, that I'll cover in the next video, then we combine the two with an or statement, and I'll show you what that looks like then. And compound inequalities produce solutions that are intersections of two solution sets. And again, this is something that we talked about, or that I talked about in the compound inequality video that you may have already taken a look at. What that means, what the intersection of two solution sets means, is that we look at what numbers are in the two solution sets, and then we take the values that are in both. Now, when we have and compound inequalities like we have in this section, we are at a bit of an advantage because these are all three-part inequalities, and so it's very obvious where our solution set is. It's between the two values that are given in our inequality statement. If you look at the larger picture of and compound inequalities, it's not always quite that obvious, and you do quite often have to graph the two together to see where they have points in common, or to see where that intersection is located. Let's take a look at how we take an absolute value inequality and put it in the form that we need to be able to solve by using a compound inequality. All right, to do this, we're going to take the absolute value inequality, the absolute value of x minus 10 is less than or equal to 2. Okay, now just like with the equations, you need to isolate the absolute value first, which we don't have to do anything with this one. It's already by itself. And then what you do is you create two separate inequalities. Now, you can do this one of two different ways. You can either work them separately, as in you would come down and create, literally. I didn't mean to put that. It won't be absolute value anymore once you rewrite it. You make an exact copy of it, except you drop the absolute value bars, and then you drop the bars, and you change two things. You flip the inequality symbol, and you change the sign, okay? This is the same way we'll be doing the greater than, so some people are more comfortable doing them all the same way. But if you remember from when we were talking about the compound inequalities, since both of these inequalities have the same variable part, you can actually write them as one. We would put the smallest constant first, that's the -2. And if you look at this inequality symbol right here, it's pointing at the -2, so we continue to point at it. Then our variable expression comes next, and then our larger constant would come last. Notice that both of the inequality symbols are the same as the one that's in the absolute value. So a lot of people just go straight to this form, and if you want to do it that way, that's fine. You can do these as three-part inequalities. Just keep in mind that when we do the greater than absolute value, they cannot be written like this, okay? They have to be done separately because they don't produce an and, they produce what's called an or compound inequality. It's a little bit different. All right, so from here, what we would do if we decide to solve it all at one time is we need to isolate x in the middle. So I would need to add 10 to each part of the inequality. Let me scoot down just a little bit so we got some room. That's going to give me an 8 here. less than or equal to x less than or equal to 12. X is between those two values. That's your inequality notation. If you want set builder, x such that 8 is less than or equal to x less than or equal to 12. The graph, we would mark the 8 and the 12, and we'll graph between them. We do need to use brackets because of the or equal to's, okay? So we shade between those two. Remember, or equal to's get brackets. If it's just less than or greater than, you will use parentheses. And then if we need the interval notation, sorry, we take the interval notation from that graph, and what we need to do interval notation are the symbols and the numbers. So I get a set from 8 to 12, and I use brackets on both ends because both ends have or equal to's, okay? So those are your three different forms. You have set builder, you have the graph, and then you have the interval notation, okay? I think the homework for the absolute value problems asks for interval notation. I can't remember right off the top of my head, but I think that's right, okay? Let's look at another one like this. Let's do the absolute value of 2x plus 1 minus 3 is equal to 5, okay? So you know what you got to do first. You've got to isolate the expression by adding 3 to both sides. So 2x plus 1 is equal to 5 plus 3 would be 8. Okay, now write your I'm sorry. I am so sorry. That needs to be less than, not equal to. We're here in La La Land. So we've got less than. So we can split it up and write it into two pieces, or if you choose, you can just go ahead and write it in that three-part inequality. Why don't we do that so you can see how it goes straight to that? You would take the opposite sign, which is going to be a negative, okay, of the constant. Then you put less than, and you put 2x plus 1 less than the positive of the constant. Okay, that gives you your three-part inequality. And then what we do is we solve for the x in the middle by subtracting 1. We need to isolate x, so we subtract 1. That gives me negative 9 less than 2x less than 7. Then we divide through by 2, so we are going to get some fractions. Negative 9 halves less than x less than 7 halves. Now the fractions are not that big a deal, because with any of the notations that we write, all we have to do is write our number down. We're not actually calculating anything with it once we get to this point. So set builder, x such that negative 9 over 2 is less than x is less than 7 halves. And we close. Graphically, we would just have a negative 9 halves and a 7 halves. Now, the symbol that we use will be different this time because it's just less thans. We don't have a less than or equal to, so you use a parenthesis instead of a bracket. That shows that you're not including the number where you're marking it. You're not including the endpoint in the set. And then from there to go to interval notation, again, you use the same symbols. Parentheses on both ends, okay? So set builder, graph, interval notation, okay? All right, now let's talk about the special cases for the less than for just a minute. Now the special cases for the inequalities are tied pretty closely with the special cases for the equations. Okay, and so what we're looking at is what happens if your absolute value is either less than or equal to a negative. and what happens if your absolute value is less than or equal to a 0, okay? Because when we are equal to a negative, remember, there's no solution. If we're equal to 0, we only get one single answer, okay? And so we have to consider what's going on with inequalities in those cases. So let's just take a look at what might happen for each one of those, okay? If we have, and I'm just randomly coming up with something to put inside the absolute value bars, that part really doesn't matter. If we have that less than a negative number, we'll say -6, but it could be any negative number, okay? Less than a negative, okay? Now, if absolute value can't be equal to a negative, could it be less than a negative? Let's think about that. What types of numbers are less than -6? They're also negative, correct? So it can't be less than a negative number. This is a no solution. So if you have absolute value less than a negative number, you get no solution. Okay? Well, what about if it's less than or equal to? Well, the situation is the same with less than or equal to. We'll just take a look at the exact same values here. Less than or equal to a negative. Sorry, my stylus is not picking up completely here. Less than or equal to a negative. In that instance, think about it again. We know it can't be equal to it, and we just saw that it can't be less than. So this is also no solution. So basically, if there is a less than involved, whether it's equal to or not, a negative, you have no solution, okay? So we can write that off. That's one of our special cases, so you want to watch out for that. Now, that will be different when it's greater than, okay? And I'll address that in the next video. Now let's talk about what happens if it's 0 instead of a negative value. Just go ahead and pick up another page. This will be our with 0 special cases. So let's say I've got something like x plus 1 is less than 0, okay? Less than 0. What are numbers that are less than 0? They're negative, okay? And we already know that absolute value cannot be a negative. So if you've got absolute value less than 0, that's also no solution. So there are 3 cases where you get no solution. Okay. Sorry about my U there. That looks even worse. So if we're less than or equal to a negative, or if we're less than 0, then we have no solution, okay? Now, that leaves us with one more situation. What if it's less than or equal to 0? Now, we can have absolute value equal to 0, okay? That one little condition is the only special condition that we have that will actually work out. Okay, it can't be less than, but it can be equal to. So the way we do, what we do here to fix that, is we just take the equal to only, okay, and we solve for that. So we'll drop the absolute value bars, because remember, when it's equal to 0, you only get one answer. And the only time that this will work is when x is equal to -1. We don't get a solution. Well, we do have a solution set. It's just not an infinite set like it has been on all the rest of them. We get a single value. That's our solution for this one, okay? So that's the only time out of these special cases that we'll actually get an answer. The rest of them are no solution. All right, that does it for the absolute value less than. I'll pick up in the next video with the greater than situation.